This is section 1.3, Algebra 2, Function Operations and Compositions. Let f of x equal 4x minus 1 and g of x equals 2x squared plus 3. What we're going to do is we're going to perform each function operation and then find the domain. So I'm going to focus our attention on 3. And if you notice, we have parentheses g minus f, which actually means, and I'm going to write it here, g of x minus f of x. So you're going to have to go to what was given to you. In this case, we know that g of x is 2x squared plus 3, and we know that f of x is 4x minus 1. So what I'm going to do is I'm just going to substitute what I know. So g of x is 2x squared plus 3. So I have 2x squared plus 3 minus f of x is 4x minus 1. You notice that you have a minus, so make sure that you have a parentheses because you are subtracting the entire function. And I'll put an equal sign here, and I'll put an equal sign here. Now, what you want to do is you want to scan, do I have another x squared? I don't. So you're going to write 2x squared, 3 minus a negative 1, that becomes positive. So it's actually plus 4, and then you have a minus 4x. And then you want to write it in the correct order. You want to write it in descending order, the powers. So you have 2x squared plus 4. Let me correct that. Minus 4x plus 4. If you look on the upper right hand corner, I went ahead and did a sketch of the graph. Now we're interested in the domain. So we're actually looking at the x values, the set of x values for this function. And I know that it's going to be all these here. And just remember, like I've taught you in the past, it's going to go from negative infinity to positive infinity. So the question is, what is the domain? So the domain is from negative infinity to positive infinity, or what most teachers tell you is all real numbers. Remember, this is going to describe the domain. At this time, I'm going to go ahead and do number 4. I'm going to give you many examples, and this is one where you're multiplying. We know that we have f of x times g of x. That's what it means here. F times g is f of x times g of x. And I'm going to try to do it here. It's going to be a process. So we have 4x minus 1, and then times 2x squared plus 3. So what is it going to require us? It's going to require us to do the FOIL method. And I'm going to go ahead and show you here step by step. So we have 4x times 2x squared, which is going to give you 8x to the third power. You have 4x times 3, which give you plus 12x. Now you're going to multiply negative 1 times 2x squared, which gives you negative 2x squared. And then we have negative 1 times 3, which gives you minus 3. You want to make sure that you're writing it in the correct order. So in descending order, the exponents, so you have 8x to the third power minus 2x squared plus 12x minus 3. What I'm going to do is I'm going to go ahead and give you a sketch of this graph. So there's a sketch of the graph, and if we're going to be looking at the domain, you notice that it's going from negative infinity to positive infinity. So the domain is from negative infinity to positive infinity, or what we say is all real numbers. numbers. At this time, I'm going to do 7. Remember that you are using f of x, which is up here. It says let f of x equal 2x. In other words, function f is 2x. And they're saying to let g be x squared minus 1. And we're doing what we did before. We're going to perform each function operation and then find the domain. So let's start off by looking at 7. I want you to take a minute and I want you to tell me what you think is happening with g and f. That's right, you are subtracting g, which is function g. But what I'm going to do is I'm going to say g of x, since I have it up here, g of x, minus f of x, so it's going to be f of x. And then the next step that you want to do is you want to substitute those functions in the appropriate, where they're supposed to be at. So for example, g of x is x squared minus 1, so you're going to substitute x squared minus 1. F of x is 2x, so you have minus 2x. And of course, it's not written in the right order, so you're going to say x squared minus 2x minus 1. I'm going to go ahead and pause the video, and then when we come back, I will graph this, and then we will determine the domain. So here's my graph. And I'm going to go ahead and sketch it to the best of my ability here. And all we're interested is in the domain. So if I come back and I were to just focus on the set of x values for this function, you notice that it's going from negative infinity to positive infinity. So the domain is negative infinity to positive infinity, or what you can say is all real numbers. The next set of problems deal with composition. In other words, we have a function that's going to go in a function. So I'm going to randomly select problems that I'm going to do with you here. We know that it says let f of x equal negative 3x plus 2. It says let g of x equal x divided by 5. And we have h of x, which is equal to negative 2x squared plus 9. And we have j of x is equal to 5 minus x. And it's telling us to find each value. So if I look at number 11, and at this point, maybe you're not too familiar with that circle. That doesn't mean multiplication. What it does mean is you have a function h, and as an input, you're going to input whatever comes up or whatever comes out of g of negative 5. So actually the output of g of negative 5 will become the input for h. So let me repeat again. The output of g of negative 5 will become the input of h. So if you want to take a minute to think about what we have to do first. And I'm going to highlight. So you might be asking, what do you have to do first to do this problem? Well, it's asking for you to evaluate g of negative 5. So I'm going to go ahead and do this on the side. We have g of negative 5. That's the input. So I'm going to go to function g. And function g has x over 5. So the negative 5 will become the input. And that's where you got to put negative 5. You have to input in for x. So you have negative 5 over 5 becomes negative 1. So g of negative 5 has an output of negative 1. Now that negative 1 is going to go back. It's going to go back into h. So let me repeat. The input for G of G was -5. The output is -1. Now that's going to have to go into H. So what does that mean? You have H, and now the input is the output of G. So this is -1. So now you got to find H of -1. So let me go ahead and do this right here, and I'll use a different color. I'll use the blue. So you have H of -1, and I know that H is -2 parentheses -1 squared, -1 squared plus 9. I know that -1 to the second power is +1. So you have -2 plus 9. -2 plus 9 gives you 7. So what we end up as our final output is going to be 7. We're going to go ahead and jump to number 20. Once again, that circle that's in between the F and the G does not mean multiplication. It means that you have F, and it will take the input of G -2. So we have to first evaluate G of -2, and then whatever comes out of G of -2 becomes the input for F. Therefore, we need to find G of -2. So I'm going to go ahead and evaluate G of -2. The input is a -2. So the function that we're going to be looking at is this right here. This is the function, G. We're going to look at G. And we're going to substitute x with -2. So what do you get? You get -2 divided by 5. Okay. I know some of you don't like to work with fractions. In this case, what we're going to be working with is G of -2 gives you -2/5. So now what you're going to do is that G of -2 is going to take the output of G of -2, which is -2/5. So G of -2 comes out to be -2/5. So now we are going to use F. So we have function F, and then we're going to input -2/5. And so what do you have? You have -3 times -2/5 plus 2. So -3 times -2 is going to be 6/5 plus 2. You want to get a common denominator, you have 5, so it's 6/5 plus 2 times 5 is 10, so it's 10/5. So 6 plus 10 is 16/5. So the final output for F of G of -2 is going to be 16/5. So remember that our output for G of -2 was -2/5. That became our input. That became our input for F. And then I multiplied -3 times -2/5, which gives us a positive 6/5. A common denominator is 5. So I multiplied 2 times 5, which gives us 10/5, plus 6/5, which gives us 16/5. I'm going to go over 23. Before I go any further, I need to know what I'm working with. I know that G That's a function I'm going to be working with. G is going to be x over 5. I know that f, I'm going to have to write down the functions I'm working with. I know that g is going to be x over 5. And I know that f of x is equal to negative 3x plus 2. So this is composition. I have g, function g, that will pass or that will take in function f. So let me see if I can highlight and make it easier to understand. So I know that function f is the expression, equation negative 3x plus 2. So you are passing in that equation. In this case, it is f of x, which is negative 3x plus 2. So what you're going to write on your paper, you're going to write first, you're going to write g, and then in that parentheses, what you're passing in, you're going to write negative 3x plus, and I just ran out of room, plus 2. So this is your input. Yep, your input is an equation, or it's an expression, negative 3x plus 2. So now you will have to use function g. So you have g, and you have negative 3x plus 2. That's what you're passing in. I just erased the equals there. You have negative 3x plus 2. So how's that going to look like? I know that g in the denominator has 5. You see that? So now instead of having an x, or the variable x is going to take the place, is going to be replaced, or going to be substituted with negative 3x plus 2. And that's it. You're done with this problem. You don't have to go any further. What do we mean? G of negative 3x plus 2 is going to be negative 3x plus 2 divided by 5, and that's it. You don't have to go any further. You finished the operation. Okay, so just to repeat, you are passing in an expression into the function. In this case, the function was, or the expression was, a function is f of x, which is negative 3x plus 2, and I didn't get to write that. Oh, it's right here. F of x is negative 3x plus 2. That went into the function. So now wherever the variable is, it's going to be replaced by the expression negative 3x plus 2. So if you want to think of it, this is like your parentheses right here. This is your parentheses. That's your parentheses. That's your variable. But now, instead of having the variable x, it's replaced with negative 3x plus 2.